Hello, good day, welcome back. In today's lesson, we're looking at the concept of normal curves. We've been looking at normal curves before now, but the particular thing I want to do here is to solve some questions and then see how we can use the normal curve to determine probabilities, which we've been doing anyways, but at least just link it up in this lesson and then to also use it to calculate frequencies of maybe an event, etc. like that. Now for this whole thing, we know that we are basically looking at the normal curve. Okay, we have this, a normal curve like this, and then a mean of a particular value. So having a mean of a particular value. Now we know that the values to the right hand side, right? So we have the first one. So we have the mean plus one standard deviation. How do I write it? That is going to contain it. So mean plus one standard deviation. We have the mean plus two standard deviation, and then eventually we have the mean plus three standard deviation. So coming to this part, so you have the mean minus one standard deviation, then the mean minus two standard deviation, and you have the mean minus three standard deviation. All right, so standard deviation being represented with this thing looks like an R. Okay, and then if it was variance, so it's going to be this square. Right, but for standard deviation, we just have this and then when we convert this, okay, you also have to remember that 68%. We've been discussing these things, so it should be sticking right by now. So 68% of all values, okay, in a particular data set, as long as it is normally distributed, so 68% of the values will fall between the mean plus or minus one standard deviation. So what I'm trying to say is that the mean plus or minus one standard deviation, you have 68% of all the values falling around it. Now the mean minus the mean plus or minus two standard deviation, you're going to be having 95% of the entire values falling in between the mean and plus or minus two standard deviation. Then finally, the mean plus or minus three standard deviation, you're having 97.5% of all the data sets, falling within the mean plus or minus three standard deviation. So literally, these are not things that you don't know. So from here to here, so you have 68%. From here to here, um, so this is the one where you have 95%, and then from here to here, so we have 97.5%. So all these things that should have stopped by now. And at the end of the day, we also learned, like on previous lesson, that we can convert this into standard normal curve. So which is just asking us like express the deviation from our mean, right, in terms of standard deviation. So if you remember that formula, and the formula that will give us our z-score, formula that will give us our z-score is just a particular item of x, like a particular value of x minus the population mean divided by the standard deviation. So we just pick one value, of x minus. Let me just use x. All right, because in statistics, the small x means deviation between the big X minus the mean, and if you see the small y, it means deviation between um, y, a value y, one of the values of y, okay, and the mean. So if you see something like x, y, right, it simply means maybe sum of x, y, for example. So you're having this thing means sum of x minus by x, right, then y minus by y, or something like that. Okay, so having understood these things, by the time we solve this problem, we are going to be having a z-score of something that we are now going to use a standard normal table to look for and then get a probability value that corresponds to the area under the curve, right? So the area under the curve, I think I can just erase all of these ones. To express this as a standard normal curve, which we've done in the past, our mean here is going to be 0. So 1, 2, 3. It should be a minus 1, minus 2, minus 3. That is When you try to use this guy. So what's this zero reason? What it means is, anyways, given that a data one observation of x is equal to a value that corresponds to the mean. So let's say x equals 20, and the mean as well happens to be like 20. So these are the beginning. So x minus the mean, or standard deviation, is definitely going to give you a 0. So the case where we are going to be having values greater than the mean, you'll be getting positive values on this side. So if a particular observation is like 50, then minus 20 over the standard deviation, you'll be expecting to get a number that will be greater than, let's even assume that this one was like a 2, right? So this is 50, this 30 over 2. What was the, anyway, so this can be, no, don't let me say this one was a 70. 70 minus 20 over 2, this is going to be 25. 70 minus 20 is 50 divided by 2, that's 25. So in this case, you see that it's going to be a value that is greater, than the mean, right? Which a mean of, we got a mean of 20. So if you have a value of x that is greater than the mean, of course, you'll be getting positive values. So what you get to be more than 0, positive values. And then if you have a number that is lower than the mean, all you are going to be getting, so let's say like you had a 10, so 10 minus 20, that kind of a thing. So you are going to be coming towards the negative side of the mean, right? So, and depending on standard deviation, eventually to now give you what number exactly you are going to be having here. Now you should also remember that all the area under the curve, the sum of the area under the curve is equal to 1, right? The sum of the area under the curve is equal to 1, which also corresponds to the probability values. So if you get an area of 0.2, it means the probability of 0.2, right? An area of 0.5 means probability of 0.5, blah, 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 blah. So just understand that the areas, the area, sum of the area under the normal curve, right, is going to give you 1. So this is just like a preamble to what we really have to do. That's what I want us to do, to solve a question, 2 questions actually. So the first one says the mean weight. So we'll be talking about weight. Example. So it says the mean weight of 500 students. The mean weight of 500 students. So we have 500 students, n is 500 students. Right, and then the mean weight of 500 students in a certain college is 151 pounds. So the mean weight is 151 pounds. Okay, where pounds is the unit of measurement, and then the standard deviation is 15 pounds. Standard deviation is 15 pounds. Okay, and then so the next is assuming the weights are normally distributed. We are talking about the normal curve. So we said the question is find the probability that a student chosen at random is less than 128 pounds. That's the first one. So what's the probability that a student chosen as random is less than 128 pounds? So what we have to do is, okay, we have to start working with our normal curve. So the mean here is 151, and then less than 128. So 128 is around 128 around here. So the question says find the mean that somebody chosen as random weighs less than 128 pounds. So literally what we are looking for is this area. So the area to the left of 128, that's what we are looking for, right? The area, we've been doing things like this, right? So this should not be a problem. The area to the left of 128. So what we have to do is that we are going to be using this our z-score formula. So literally, our z-score is going to be equal to, what is x? X is 128 minus 151 divided by 15. So you have minus 23 over 15. So which is going to give us minus 1.53 minus 1.53. So let's just use the whole thing into the decimal place. So now we are going to check our normal table, the negative normal table. That's what you're going to check, right? Which of course you downloaded, and then you know how to use it now. So by the time we check our standard normal table, under the negative, so you check 1.5 under 3, right? So in your standard normal table, we write that one here. So what we are checking is minus 1.5, then you have 0.00, 0.01, 0.02, 0.03. So we are going to check minus 1.5 under 0.03, And then when you check that, what we're going to have is 0.063. So at the end of the day, so the z-score is 1.53. So the probability of x of the is it x? This is not meant to be x. Well, x is less than, so the probability of the z-score, the one that we're looking for exactly, okay, being lesser than minus 1.53, right? Because we've gotten a z-score 1.53 here, right? So the probability that what we're looking for is lesser than minus 1.53 is equal to what is it? Is approximately 0.6, 0.06, 0.06301. So that's the answer to the first question. As this was the probability that somebody chosen at random is going to weigh less than 128 pounds. So just find this is 128 pounds. We got is this score. So the value of this whole thing to the left. Do you understand? Because all of this will be showing that it is less than 128 to the left. All right. So let's look at a different question. What is the probability that someone choosing at random is between 120 and 155 pounds? Between 120. So we are literally looking for P of between 120 and okay, we have not even gotten this. Let's calculate this. Okay, so we have a mean of 151. Okay, so it says between 120 and 155 pounds. Between 120 and 155 pounds. So what are we trying to like look for here? So we're going to calculate our z-scores. We are convert it into z-scores. Now, if you look at this well, between 120, so what we are looking for, the z-score that we are looking for, right, which we are going to get is probability, is a value that is going to like fall somewhere here between 120. So which means that we don't need this part, right? And so what do we do? So that means we are going to get the value of our z-score to the left, right? To like we eliminate this left. Now, you know, by the time you get to 155, 155 is talking about, okay, let me do this. This 155 here, right? To the left of it covers this entire area, right? Everything is entire area, but we don't need everything. What we need is just this entire area and like these parts. So because this is where your 120 is going to be, so that's what we need. We don't need the entire area, right? So what we have to do is that this entire area minus where this one was 120 here, 120 here, you know, this guy adds this area. So this entire area minus this one will give us what is left, which is what we are looking for. Give us what is left. Right? This area in between, which is what we are looking for. Right? So all of this area minus remove this one, give what is left. So what we have to do now is that we are going to find two z-scores, because this score that we actually need, probability that we actually is in between. So find the two z-score. For the first one, we are going to be having 120 minus 151 divided by the standard deviation is 15. And then we are going to have 155 minus 151 standard deviation of 15. So when we do this, you know, z1 like z2. So 120 minus 151 is going to give us minus 31 over 15. And this is going to give us 4 over 15. And so minus 31 over 15 is going to give us minus 2.07. So equals minus 2.07. And then this one equals 4 divided by 15 is 0.27. 0.27. So at the end of the day, what we are exactly looking for is where's the minus? So we are our probability that we are looking for now is the probability, okay, minus 2.07 lesser than Z that you are looking for, what is in between, then this one lesser than 0.27. So we find the probability value that corresponds to this, find the probability value that corresponds to this, we subtract them. So whatever we have left is then the solution to our problem. So like that's what we are supposed to do. Now when you find the probability of this guy of minus, 2 point, is this score of minus 2.07. So the probability of that, okay, well, let's just write it this way. That's the probability of minus, okay, let me continue from here. So the probability of this one, of this lesser than z lesser than this, is going to become minus 2.07 will give us a probability of was it lesser than, so 0.6062, so 0.6064, 0.6 or 0.06, this is 0.64. Anyway, let's do 6064, then minus probability of 0.27. Which one gave us 0.27? Minus 2.07 is giving us, okay, because I was wondering, right, because it is 0.27 that gives us this, and minus probability of minus 0.27 is going to be 0.0192, 0.0192. So x lesser than 0.2, z lesser than 0.7, probability of z lesser than this is 0.6064. Probability of z lesser than this minus z greater than this one is minus 0.0192. So you subtract them, and then we are going to have 0.5872, so approximately 0.5872, right? So this one is going to give us a greater probability. This is like the higher value, which is this, and use your standard amount table, and then minus here, which gives us a lower value. So we want for minus 2.07. So when you find that, this is it. So the area, all the area corresponding to 155 minus the area corresponding just to this small part, whatever is left, which is this middle, that's the probability of getting it. So the third one that we now have to do. So I hope you understand what bit that we're doing is not difficult. It is not difficult. We've been finding z scores and all of that. Just that the difference between this and the previous lesson is that we didn't start from, let's say, non-standardized values. So we're just solving when the z-score is this and the z-score is that. So calculate distance between, calculate like the area covered between this z-score and that z-score. That's what we did. So which means that this class is just like a step before that, because now you are the one that needs to first convert whatever values you're given on your standard amount to the standardized form using this formula. So you get your z-score. So instead of you being given your z-score, you get your z-score by yourself, and then you now continue from the other things that we've been doing in those previous lessons. So let's look at number 3, and then look at the final question that will lead us with simultaneous equation, and then we call it a day there. For number 3, our job is to look for the probability that someone chosen at random is going to weigh 185 pounds. Probability that someone chosen at random is going to weigh more than 185 pounds. Okay, so let's cook more than 185 pounds. So draw your normal distribution again. So remember that the mean is 151. So we are looking for someone that is more than 185. So literally, what we are doing is that we are looking for the probability beyond 185. So like 185, like to the right. That's what we are looking for, because the question says more than 185 pounds. So 185 to the right. So using our formula, what's this score corresponds to that? 185 minus 151 over 15 is going to be like a 34 over 15. It's going to be a 2.1, is it 2.1, 2.2 something, 2.27 is going to be equal to 2.27. Now look at it. Standard normal table will give you the values to the left of your z-score, to the left. But here now we are doing value to the right of our z-score. So which means that by the time we get what do you call it now? And remember that the total area under the normal of is 1, right? So by the time we get the probability value of 2.27, then we need to subtract 1 from it, once we've been used to. Because what we are going to get is the value to the left. We are going to get just all of this part. But what we are looking for is the last part. Then we know the total stuff is 1. So 1 minus probability of the 1 minus the area of the remaining this part to the back will give us what is left. Do you understand? So here we are going to have probability of z greater than 2.27. That's what I want to do. Okay, the one that I've been doing lesser, whatever. So, but this one is greater because what we want to get now is something greater than 2.27. Like this is 2.27, where this is 0. Standard normal call. Like, do you understand? So 0, 1, 2, 3, then minus 1, 2, 3. So just I'm just like doing as if I've converted the whole thing. I've actually like converted the whole thing. So here, this is going to be equal to 1 minus, then look for 2.2 in the positive z-score table or the positive normal curve table. So 2.2 under 0.07, and then that is going to give us 0.9884. 0.9884. So at the end of the day, this is going to give us 0.0116. 0.0116. So the probability of selecting somebody out of the 500 people that is going to have a height more than 185 pounds is 0.0116. So what this is probably saying is that we have most of the people under 185 pounds actually, because 0.0116 is small. Look at this probability of having people like around 185 whatever is like before like probability of having people that are either below or like 185 pounds exactly. That's one that gives like 0.9884. So most of the highs like they are falling below 185 or like 185 at best. Right, so the remaining those that are like extremely tall, probability of them, so they are kind of scarce, is 0.0116. So and nobody's asking me for that though. I'm just trying to like explain the answer, because remember that what we're doing is meaningful statistics, what is like kind of making sense. Now this next set of questions, so one thing that we've done before is a part of this question. So the next set of questions is now find how many students weigh 128 pounds. So this thing is actually simple, right? So we are going to be doing things like expected value that we did that time. And if you remember the formula for getting expected value, that's the probability of something, an event multiplied by the event itself. So like the probability of x multiplied by x. So number of those that weigh less than 128 pounds, number of heights below 128 pounds. So it's just equal to the probability that we got for this question. So the probability was 0.063. So we have 0.0630. That was what we got. Just multiply by 500, the number of students, and then we are going to be having 31.5. So this equals 31.5, but this cannot be people now. So we approximate it to 32 students. Like that's all. Since we've gotten the probability before, so that's I. How about I? So number of heights between 128 and 151 pounds, 155 pounds. So we got our probability for that as what's the probability for that? 0. Where's number 2? 0.5872. We got 0.5872. Just multiply this also by 500, and then we are going to be having 293.6, 293.6, which is approximately 942, because we are talking about human beings. So we need to like approximate to whole numbers. Now the final one, which is something that you can do, is number of students, number of students above 185 pounds, 185 pounds, and this one now equals to the probability that we got here, 0.0116 multiplied by 500. So this one on its own is going to give us 5.8, 5.8, which is approximately 6 students. So don't do the mistake of saying, oh wow, I already got this, and I already got this. So add it all them together, then subtract the final answer from 500. Don't do that. Don't do that. That's not going to be very correct, because if we add this to this, we get this something like around 3 to 6, then plus 6, 3 to 8. So there are still heights that, might be much more than 1 is 5. Like there are still heights that might be much less than where we started from. Like started from the list that we started from was what do you call it? The list was like 120, right? Yes, 120. But there are people that might fall below 120. So don't go and do the mistake of like, oh, there are 3 questions. I've gotten this, add them up, subtract them of 500, whatever you have left. That's not correct. Because we started from like, what I mean is I started from like 120. There are still people that may fall here that we did not capture it like that. So just do your normal solution, right? And then enjoy, yourself. So this is about the first, question. Now the second one that we want to go to, so let's look at it briefly. Look at this question. Esther believes a company is allowing too long for a job and invites them to time her. So they find that only 10% of the components take her over 90 minutes to produce, and where is it? To make, and that 20% of the components take less than 70 minutes to make. So estimate the mean and the standard deviation of the time Esther takes. So what we're used to is we looking for the probability, which is the area, right? But now the question has actually given us the area, so we have to like go back to look for the standard deviation and the mean that we can work with. So how do we interpret this question? So first and foremost, the mean you don't know, standard deviation you don't know. But what do you know? It says that Esther believes and invites them to timer. So they find that only 10% of the components take over 90 minutes to make. So this is in terms of time. So you have 90 minutes. Only 10%. They've given the area, they've given the probability value. So if the probability of something, if the probability of something is 10%, so if you want to convert it, that's 0.1, right? So what this 10% means here is an area corresponding to 0.1, right? And then the other one says to make an 20% take less than 70 minutes to make. There's 70 minutes here. 70 minutes, less than 70 minutes. So you are coming to the left of 70 minutes. So which is 20%. So you have 20%, right? And where is the answer? Less than 70 minutes to make. So this is going to be corresponding to an area of 0.2, right? So we are looking for, we've been given the area like to the right of 90, then we're given the area to the left of 70. So how exactly then do we like begin to like walk around all of these things, right? So once this score will correspond to an area of 0.2, once this score will correspond to an area of 0.1. So here you've been given the areas. So what we need to go and look for is the z-score. Now the z-score that will correspond to the area of 0.2. So you now go into your table, right? You go into your what do you call it now? Your How do we even know that this is going to be negative? Because you're never going to find 0.2 in the positive, what do you call it now? In the positive normal table. You will not see 0.2 there. I think the list is probably like 0.5 or something. So where you're going to see 0.2 is in the negative normal table. You need to check, like, okay, I like that, just open it up. So the list, when you just begin to go through it, so you can see 0.2 and all of that. So, but 0.2 would never be in the standard in the positive table. So that's what is even giving us an idea that this guy, what we've drawn here is right, but it's pointing towards the negative side. Now, what I'm really saying is that gives us the idea that this isn't the mean, this is 90, and then 70 is probably here. So because if 70 is probably here, it shouldn't be a negative store. Do you understand what I'm trying to say here? So for it to be negative, then it has to fall below the mean. Do you understand? So that is what is happening here, because we can't get 0.2 in a positive table. So what we've drawn here is correct, right? But if this had been like maybe like 70%, for example, right, you'll be able to get that one, right? But is it 0.2? Okay. Anyways, so we have 0.2. So next thing that we'll now look for, check the z-score. So by the time you begin to check for your z-score that corresponds, z-score that corresponds to the area, so the area of 0.2 is going to be equal to where is it? Minus 0.85. Minus 0.85. So go and check. You really want to discover this by yourself. So minus 0.8 under 5. Do you understand? Now it's not as if it is exactly going to be 0.2. I think it's 0.199 something like that, right? So someone else may say the answer is minus 0.84. Do you understand? So sometimes those because there's no 0.2 exactly, so sometimes those disparities could exist. So another person gives minus 0.84, another person gives minus 0.85. I think there should be room for small, errors, right? Now, the other one that I want to go and look for is this score. Is this score that corresponds to the area of 0.1 to the right, right? 0.1. So this is to the right. So technically speaking, what we are looking for is not even 0.1. What we are looking for is 0.9 to the left, right? Because if you have 0.1 to the right, it's correct. Because you will not even find 0.1, so therefore positive. So if you have 0.1 to the right, so it's the same thing as saying 0.9 to the left. So what you are actually looking for in that table, right, is 0.9. Is this score that corresponds to 0.9 to the left, right? 0.9 to the left is the same as 0.1 to the right. So go and check what is this score that corresponds to the right, which is that is z-score that corresponds to the area of 0.9 to the left. So now you are going to find 0.9 to the left in your positive z-score table. So go and check. So you are going to have z of 1.28. So that's what you're going to have at the end of the day. So z of 1.28. So again, it will not be very, very, there's room. Do you understand? So for the first one, this guy, so z-score, this score is literally x minus the mean by standard deviation, right? So you know it is minus 0.85 equals, what is your x? 7c. 7c minus your mean divided by r. We don't know. So minus 0.85 r equals 7c minus your mean. So this is, one equation. Which one did I even make the subject? So I just want to do things that 7c minus mean equals this. So, and then the mean, I think the mean, the mean is then going to be equal to 70 plus 0.85 standard deviation. 70 plus 0.85 standard deviation. Okay. Now for the second part, so the same thing. So this is like the z1. So you have your z2, which is equal to x minus. So should I add x again? No need. I just write 90. 90 minus the mean over the standard deviation. So z2 gave us 1.28, right? Wait, I thought I wrote it. Okay, 1.28. So 1.28 equals 90 minus the mean. All right, so we are going to be having 1.28 is equals 90 minus u. All right, so which is like 90 minus this equals 1.28 r, like it's the same thing. So I just substitute the value of u here. So I have 90 minus open bracket 70 plus 0.85 this equals 1.28 this. So going on, so 90 so you have to be careful. 90 minus 70, then this times this minus 0.85, okay, 1.28 so you have 20 equals 1.28 plus 0.85 this. So 20 equals 1.2 plus 0.85. Did I even bother? So 2.13, 2.13, so 2.13 this. So from here, our standard deviation will be 20 divided by 2.13, 20 divided by 2.13, and then the standard deviation gives us 9.4, so approximately 9.4 minutes. Standard deviation is because the whole thing is in terms of minutes, so don't forget 9.4 minutes. All right. So and then recall that there's a relationship between, so if this is 9.4 minutes, then what is the mean? So the mean will come back. We use this equation 70 plus 0.85 into brackets 9.4 minutes. So the answer here is approximately 77.98 minutes. 77.98 minutes. So you can see that from our results, right? 70 falls below 77.98. It falls at the back. 77.9. So when you're drawing, just be careful. Right? So just be careful. Again, I've explained the fact that 0.2, right, is going to be in the negative part, right? You could get it. But you can't say 0.1 is in the negative part because really 0.1 would have been negative part if it had fallen to the left. Do you understand? But since it is to the right, so what you're looking for is 0.9, not actually 0.1. I hope that is fine. So just be careful about all of these things. So with this, we've solved the question. So our mean is 77.9, approximately 77.98 minutes, and then our standard deviation is 9.4 minutes. So there might be little decimal differences, right? For example, you may get 77.93 here. So 77.93, 77.9, that's like a gap of 0.05. Okay, which is still kind of should still be acceptable. You understand at the end of the day. So yeah, that's it. So I hope you understand the whole thing. Settle down, study it. You're going to be fine. So what we have to go and do next is an assignment. So our assignment, a machine is set to produce nails of length 10 centimeter with a standard deviation of 0.05 centimeter. So length 10 centimeter with standard deviation of 0.05 centimeter. Now the lengths of the nails are normally distributed. So A, find the percentage of nails produced between 9.95 centimeter and 10.08 centimeter in length. So of course the mean in the equation is going to be 10 centimeter, and then the standard deviation is 0.05 centimeter. So that's like the first thing to know. And then, so the first question is to find the percentage of nails produced between 9.95 centimeter and 10.08 centimeter in length. So what's the percentage? You get a probability and there must be a probability by 100. So just like the question we just finished. So we're given a percentage, 20%, then we converted it to decimal 0.2, area 0.2. So yeah, you're going to get probability values multiplied by 100. That's the percentage. Finish. Now the machine settings, the machine setting is moved by a careless apprentice, with the consequence that 16% of the nails are under 5.2 centimeter. 16%, they give you percent now, so convert it to decimals, are under 5.2 centimeter in length, and 20% are over 5.3 centimeter. So find the new mean and standard deviation. So this is just like what we just finished doing exactly. So this question covers everything we've done in this particular lesson, and I wish you the very best at it. Thank you very much, and see you in the next class. Bye.